Today we're going to be talking about step functions and the greatest integer function. Now a step function is a piecewise function that is constant for each interval, which means that it's a straight line. Okay, we talked about the constant function. So we're at y equals -3 for x is less than -2. So I go to that point right there, open circle, all the way to the left. And then I'm at +4 from -2 all the way over to 6. And then I am greater, I'm at 7. There's a 4, 5, 6, 7 for x is greater than 6. So that's a function, step function. Kind of looks like steps. The greatest integer function is a specific type of step function. Okay, and this is what the greatest integer function is. So you need to know that when you have that, when it's written like that, that's what that means. And what the step function, what the greatest integer function means is it's the greatest integer less than or equal to x. Okay, so it's the greatest integer less than the number we're given. Okay, so it's kind of like rounding, but you're always rounding down. Okay. Okay, so 3.25. Okay, what's the greatest integer less than or equal to 3.25? Well, that's 3. Greatest integer less than or equal to 5, that's 5. Or 5.78 would round down to 5. So even though normally we'd round that up to 6 if we were going to an integer, it's less than or equal to. Now, what's the greatest integer less than or equal to -4? Honestly, what I did when I was thinking about how I was going to explain this to you guys, I set up a little number line. And I said to myself, 4.12, -4.12 is about right there. What's the greatest integer less than or equal to that number? -5. You're rounding down. So here, I would round down to -8. So what does that graph look like? It looks like the graph looks a little different than something we've ever looks very different from something we've ever seen before, I should say. Okay, what they are, they're little bars. Okay, and it's a step function. So all of these are possible values. So when you look at that, I have a closed hole at 0 because it's greatest integer less than or equal to the 0. So anything from 0 to 1, but not including 1, is going to round down to 0. So that's why it's a little bar. And then I jump up at 1 because 1 is less than or equal to 1. 1.7 would round down to 1. Okay, so this is what the graph looks like. I would make sure you have that graph in your notes along with everything else on the slide. Okay, and you really have to understand that they're bars, and all we're going to be doing is translating those bars. Okay, graph the function, identify the domain and range. Remember, this is the greatest integer function. The +3 means I'm moving to the left 3 units. Okay, so let's think of what 1 bar normally would look like. Okay, 1 bar would be here. Now translate that. Let's do something fancy. Oh no, I thought I had that locked. This is really exciting. I'm really glad that you guys get to see this. Okay. What do I have to do with this? I have to translate it 3 units. Come on. 1, 2, 3 units. Okay. And that gets you your starting point. So I always start with this first bar and then I do my translations to it. Okay. My next bar would have been there. Now let's translate that. 1, 2, 3 units. 1 bar to the left of it would have been here. Again, translating that 3 units. 1, 2, 3 units. So you see the pattern now. Now that you see the pattern, you can just go through and fill in the rest. I would want you guys to show me at least 5 so that I can see that you understand where the graph is going. The domain is all real numbers, okay? Because I have all numbers here, then I jump up, all numbers, then jump up, all numbers, then jump up. The range, it's nothing in between, so it's my integers. Okay, next. Okay, the negative in front of the function, outside the function, means across the x-axis. The 3 is a vertical stretch. Okay, I'm taking the x's and I'm stretching them out. So let's get an idea. I'm just going to get a few on here. Okay, so that's an idea of what the graph looks like. Now what we're going to do, okay, flip that across the x-axis. So this bar would move up there. This bar would flip across the x-axis. Flip across the x-axis. Flip across the x-axis. And then we have a vertical stretch by 3. So, okay, so the distance between the bars no longer is 1, it's going to be 3. So this bar is going to move up to 3. This bar is going to move up off my grid to 6. This one stays where it's at. This one's going to move down 3. This one's going to move down to 6, which is off my grid. Okay, so now our domain. Again, for greatest integer, it's going to be all real numbers. The range now, okay, well, it's still integers, but those integers are a multiple of 3. Integer, we'll say integer multiple of 3. Okay, the last one. We have to do some manipulation here. Okay, remember when there's a 1/2 next to any number next to the x. What you have to do is you have to factor that out. That gets me the correct translation. Okay, so this 8 here means I'm going, let's make it an 8. I'm going left 8. Now the 1/2 is opposite of what it seems. You'd think it would be a compression along the x's. But remember, notice how everything when it happens to the x is opposite of what it seems like it should be. So the 1/2 is a horizontal stretch by 2. Okay, so let's get an idea here. So normally I would have that right there. First, then do your translation. Okay, so I translated 8 units. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's translated 8 units. Okay, now I'm stretching it out. Okay, I'm stretching it out I'm making it twice as long. So what you're going to do is you're actually going to have it be, it's going to look like that. Okay, the next one would be up here, 2 units long. 2 units long. 2 units long. Okay, and notice how when I stretched it to the left, because technically if you look at this graph, okay, that's the regular greatest integer function. If you have a horizontal stretch, you're going to stretch it 2 units to the right. Okay, you're stretching it, making it twice as long. That's not part of the graph. Just the red piece is a part of the graph. And I told you guys 5 bars, so let me be a good model. And 5 bars. Okay, again, domain, all real numbers. Here, I'm just going up by units of 1, so that's going to be integers. Okay, Step functions, there is a lot of applications of step functions. Okay? A psychologist charges for counseling sessions a rate of $85 or a fraction thereof. Okay? So, from 0 to inclusive of 1 hour, I'm going to be charged $85. From 1, even if it's a minute over, all the way to 2 hours, they're going to charge me twice that. They're going to charge me for 2 hours. Anywhere from 2 to 3, we're going to be charged for 3 hours. Anywhere from 3 to 4, I'm going to be charged for 4 hours. And then anywhere from 4 to 5, we're going to be charged for 5 hours. Okay, so what that graph looks like. And let's be good graphing. Whoa, that's a straight line, I promise. Here, let's talk about hours. Along here, we're going to talk about the dollars. So we're labeling our axes. Okay, let's just go in the increments of what we were given. 85, 170, 225, 255, I apologize. 340, since they're even intervals. Okay, now graph that. So anywhere from 0 to 1 hour, notice how filled in hole changed, we're at $85. Then here, even a minute over, we jump up over here. Okay, so that's what that graph would look like. There is your lesson question, a multiple choice question today. Please make sure that your lesson summary is submitted on time.